Right, this is the vectors and collisions example that I've put in your lesson folder. I like doing them this way. This isn't a standard textbook method as such, so see how you get on with it. And then next lesson, we'll do them using unit vectors and dot products, and if you prefer that, that's fine. So you can just choose which method suits you. But I'd like you to have a go at using both ways. And sometimes I think it's good to see different ways of doing things anyway. So we have a small smooth sphere moving with velocity I plus 5j. So something like this. I'm going to use column vectors. When it hits a smooth wall, we don't know the orientation of the wall. It rebounds from the wall with velocity 4i plus j. So it's rebounding up. So it's a cos 4 up 1. So I don't know, something like that. And the wall is going to sit something like this, so that angle is slightly smaller than that one. And the first thing to do is to find a vector that is perpendicular to the wall. The thing we know is that the impulse acts perpendicularly to the wall. And so we can use impulse is change in momentum in order to find a vector perpendicular. So the impulse is mv, which is 4,1, minus mu, which is 1,5, and that gives you m 3 minus 4. So 3 minus 4 is perpendicular to the wall. And we now want to find E, the coefficient of restitution. My method, we're basically working with finding components still parallel and perpendicular to the wall. So if 3 minus 4 is perpendicular to the wall, then if you think about your perpendicular vectors, if I flip this 4, 3, so that's equivalent to the negative reciprocal of 3 minus 4, if you're thinking about it as fractions, is parallel to the wall. And then you can actually split these vectors into components which are parallel and perpendicular to the wall. So 1, 5 is going to equal p lots of 4, 3, which is the parallel vector, plus q lots of 3 minus 4, which is my perpendicular vector. So I'm just splitting it. And then you've got two simultaneous equations through here. So 1 is equal to 4p plus 3q, and 5 is equal to 3p minus 4q. Whack that into a calculator. P is equal to 19 over 25, and Q is equal to minus 17 over 25. Then we can do the same with this 4, 1, so we can split it using the same vectors, parallel and perpendicular to the wall. So I'm equating x components or I components and j components. So 4 is equal to 4r plus 3s, and 1 is equal to 3r minus 4s, and then you get r is equal to 19 over 25, and s is equal to 8 over 25. If you look at what's happening here, this is showing you that the velocity is unchanged parallel to the wall because P equals R. So that's quite nice to see. Sorry, you're in the shadows. So velocity unchanged parallel to wall. And then perpendicular to the wall, having smudged my work, minus 17. So considering perpendicular component, so the perpendicular velocity has gone from minus 17 over 25 times 3 minus 4. So that's going in that way vertically, and then it rebounds off that way at 8 over 25, lots of 3 minus 4. And so E, the coefficient of restitution, is going to be 8 over 25 divided by, we're dealing with speed now, 17 over 25, because the vector components will just cancel top and bottom. And that leaves you with E is equal to 8 over 17. So I've put a couple of questions in your lesson folder to do on this. There's none in the textbooks, but they did come up on some mock exams. So we can't rule them out as possibly coming up. So I do want you to work through this. So there's 2 in your lesson folder, and then next lesson I'll show you a different way of doing this, but this is the way that I like, so I couldn't not show you it.